Yeah, it's in the exact same spot on the number line. But if I take that square root, I get 2 comma 180, which is like saying the square root of 4 is negative 2. So in this case, it's like you need to know whether you started at 0 or 360. I'm sorry, Rodney, I cut you off.
I said that's annoying.
Isn't that annoying? So it's like you need to know whether you started at 0, 360. What about 720? What about all the other infinite number of ways to represent being here for all the times you can go around a circle? Okay, so that is kind of annoying. So all of a sudden the system is not looking so convenient. Because instead of just saying the square root of 4 is plus or minus 2, you have to know whether you're started calling this 0 degrees or 360 degrees.
Wait, never mind.
So this would be about the point where you would pitch this system. Except for here's where an important discovery was made. Okay? Now, when we look, I started out by asking what would you do with the square root of a negative number? And the simple answer you guys said was it doesn't work. Okay? But let's follow this rule, which has been consistent up to this point. If I wanted to take the square root of negative 1 in this system, I would take that square root, that would look like this. It would look like the square root of positive 1, comma, 180 degrees. Now, by this rule, you take the positive square root of the number. What's the square root of 1? 1. Now, for every day but today, it's plus or minus 1. But for today only, we'll say that it will just take the positive root 1. And then it's 180 degrees divided by 2.
So 90.
So that's 90. So we have 1 comma 90 degrees.
Why is it 2? Yeah.
Because the rule for roots is you take the positive root of the number and you divide the root by the power.
It's invisible too, right?
Oh,
By the,
right,
you
right,
go by the
right.
parentheses. Yeah, the invisible 2 here that's in every square root.
Right.
Divide the angle by the root. Thank you. I was misspeaking. You divide you take the root of the number, divide the angle by the root. Correct. Well, here's the wacky thing, okay? We started out on a number line. A number line only has a 0 degree direction and a 180 degree direction. But this rule says if we take the square root of a number over here, it must create a new number up here, 1 unit high, at a 90 degree angle to the number line. It's created a whole new dimension. Part of the problem is we started out with a 2-dimensional representation. One length plus an angle. But it's kind of weird that we started out with this 1-dimensional line and following just the logical rules that we could figure out, we had to leap off that line at a right angle. Okay? This is actually, what happened was, okay, you can invent any system of math you want to. You could invent one right now. We could invent a system, pardon? Done. Okay, got one. All right. The question is, how is that system of math going to get into textbooks? Does anyone on God's green earth have a use for it? Okay? What it turns out is, by having a set of numbers that can be represented as going off at a 90 degree angle to a number line, you can talk about perpendicular forces very well. Electrical engineering, if any of you take any electromagnetism courses or get that far in physics, you'll discover that electricity through a circuit creates forces at right angles to the circuit. My father helped design submarines that could withstand nuclear depth charges. That's the kind of things people thought about during the Cold War. He was a scientist for the United States government, and he was always planning for that World War III with the Soviet Union his entire career. If you have a submarine and you put it deep underwater, and the water is pushing in at the hull from all directions, do you think a way to represent a force that is always pushing on a surface at a right angle could be useful?
Yes.
So this math found a way to survive. Okay? But luckily, this very cumbersome way of talking about this math did not. Anytime you've got any force acting at a right angle, electricity on a current, or if you're underwater, the water is pushing in at your skin, right? Turns out the water is always pushing in on your skin at a right angle to your skin every second you're underwater. For that matter, the atmosphere is doing that to us all right now. For that matter, the Earth is, I know, 14-point-something pounds per square inch. You're weightlifting every time you're just walking around. Do this and you're lifting
Billions of
a couple hundred pounds of air. I don't know. Yeah, you should feel strong. It takes a lot of effort just to walk upright on this planet. But we don't use this notation for this. Okay? And honestly, in Algebra 2, we are not going to get to submarine hull design or electromagnetic circuits. So you guys may actually be relieved by that. Hey, Arthur.
Oh, you missed so much. You're
All right.
gonna have so much fun.
All right. Ice cream, pony rides, it was amazing. Lottery tickets. Okay, so here's what we say instead. Okay? Now, the square root, okay, here's what we actually say and what actually survived from this. We say the square root of -1 is equal to the letter I. We use I to represent the square root of -1. And I has certain properties which we'll go into a lot of details about tomorrow. Okay? And also, I gets its own plane. This I've referred to all the things we've graphed this year as being on the Cartesian coordinate plane. People notice I've used those words.
Oh, you got 1, 2, 3, 4.
Yeah, it's got an X and a Y and a negative X, and we graph lines on it. Yeah, those were good times, Jordan. Yeah. This gets a different plane. I lives on what's called the complex plane. We'll do a little bit of graphing on that. And the complex plane has X's over here, negative X's over here, positive I up here, negative I down here. And graphs and numbers and everything else on the complex plane do not work at all the way they do on the XY coordinate plane. Totally different rules apply. Some people think the complex plane is going to be the place where we will graph things like how to get through a wormhole in space.
What's a wormhole?
Wormhole is a theoretical passageway that can take you from one part of the universe to another.
So wait a minute.
Because if space can actually bend,
If it's theoretical, it's not real.
No.
it may be real. It's unknown.
We made it up.
Does it
We
work
didn't make
in
it
that?
up. We made it up based on observations.
That's the difference between theory.
Okay? It's just like, no, I mean, it's not like My Little Pony. It didn't just come straight out of somebody's head one day for no reason. It's like, so people pointed telescopes at the heavens, watched things, and thought, you know, a wormhole would explain that. Anyway, okay, so we'll get into now. Tomorrow, now that you guys have some idea where this comes from, tomorrow we will get into the operations and what you, how to actually start manipulating imaginary numbers. Okay, and it will be very, very much baby steps. I apologize for those of you who like to know the how and the why of things, that we will not actually work on any submarine hull designs or circuits.